Hello, darlings. Welcome to your online lecture. Okay, so the purpose of this e-lecture basically is to finish up this chapter, and it will be finishing up with proteins, right? So before we start, make sure you have your notes together with you first before we start. Then, yeah, once you're ready, then you click play and go. Okay, so as of every lecture, let's just quickly just recap first. So that day in lesson we spoke really quickly, right, about water, carbohydrates, and fats. So Mr. Cho thought I tie some things down here first before we proceed to proteins. Okay, so for carbohydrates, fats, and proteins, correct? These are the five things here that you got to know. Okay, what are the elements that make up the three types of nutrients? Okay, the sources. Okay, the classification. Classification means what is the simplest unit, then what's the most complicated unit, and how do they break up and how they build up and how they break down. So for example, for carbohydrates, shall we just do a quick recap? For carbohydrates, we start off with monosaccharides, right? Just one unit of sugar. Then it becomes disaccharide, so two units of sugar. Then becomes polysaccharide, where there are many units of sugar. Can? Right, but for fats, what do we have? We have glycerol and three fatty acid chains, right? They put together, right? You'll become a fat molecule. Okay, so later for proteins, you'll do the same. You got to know how the molecules build up and break down. Can? Then you got to know the functions of carbohydrates and fats. For carbohydrates, we have our Superman story already. For fats, I do have a story, but I think you'll think about it first. Okay, when we come back, then we talk about it. And finally, the most crucial one, the test. Okay, how do you test for carbohydrates, fats, and proteins? For carbohydrates, you have two tests there, your starch test and your Benedict's test. And as for fats, you have your alcohol emulsion test. You must be able to describe them accurately. Okay, you must be able to carry them out, as well as you must be able to describe and interpret the results of the tests accurately. We'll take all this when we come back. Okay? Okay, come. Let's quickly move on to proteins first. Okay, so the five things here: elements, sources, classification, functions, and tests. For water, just know the functions can really. Four main functions of water that we spoke of earlier on in the lesson. Okay, come. Let's go. Okay, so this is a char kway teow, a good plate of char kway teow, and Mr. Cho is recording this lecture on a Sunday afternoon. I hope that you guys had your meal ready wherever you are. Okay, so you all can see, right, in the plate of char kway teow, carbohydrates are like the kway teow, right? There's the pork lard, in this case, or the which accounts for fats, and there's your prawn and your chicken, which accounts for proteins. Okay, so let's talk about for proteins in this case. Now, come the first thing, elements, right? What elements make up proteins? By now you have known, right, for carbohydrates and fats, it is CHO, right? Carbon, hydrogen, oxygen. Okay, but for proteins, okay, it is carbon, hydrogen, oxygen, and nitrogen. Okay, so the first keyword here, nitrogen, so it's CHON. Okay, then sometimes sulfur may be present, this element called sulfur. Okay, so the basic unit of proteins is amino acids. Okay, so carbon, hydrogen, oxygen, nitrogen. Sometimes sulfur may be present, made out of simple molecules called amino acids. Now, the main sources of protein, I think by now you all would know. Okay, where can we get meat proteins from? Will be from meat. So your lean meat, fish, liver, milk, cheese, egg. All these things that you are able to. Egg white. You'll be able to get protein from. Okay, so I won't dwell on too long here. All right, now let's go on to classification. For amino acids, correct, we must take a look at their structure over here. Okay, so in the middle here, okay, for every single amino acid, so amino acid is the basic unit of proteins. We start off with a central carbon first. Okay, so there's a middle C here. Okay, on top there, you're linked to a hydrogen atom. Okay, on one side of the molecule, there's an amino group. So an amino group is a NH2, so nitrogen with two hydrogen atoms. Okay, then on the other side, we have a carboxyl group. So C double bond O, then single bond OH, so COOH. Okay, and finally, there's a R side chain. I'm not sure if this thing is showing here, but yeah, it says side chain, R side chain. Then what's this R side chain thing? Okay, so the thing is that I'll take you on to the next slide and then you see. Okay, in the okay, I'm going to shrink myself a bit first. Okay, so in the real world, right, there are 20 naturally occurring amino acids, just like letters of the alphabet, right? Amino acid in the real world, you can find 20 different kinds. Now, you are not expected to know all these different names and be feel startled, but I think what we want to appreciate here, right, is the different types of amino acids. Right? You see, there's always a central carbon, right? On top, there's a hydrogen atom. Then there's a amino group and a carboxyl group. Can see now? So R is just a general letter to the side chain that we give. So this is what differentiates between the different types of amino acids. Okay, so you don't have to know, you look at all these, you don't have to know and memorize all the chemical structures. All you need to know, okay, is the basic amino acid structure, which is over here, okay, over here, okay, as well as appreciate that the R side chain, can you see now, is the one that will differentiate between the different types of amino acids. Okay, so if we are good, then come, let's carry on. So from the 20 different naturally occurring amino acids, right, you have already learned this word condensation and hydrolysis. You want to join something together, okay, it's actually a condensation reaction. So two amino acids, right, can link up together by a condensation reaction. That's the blank in your notes, right? Condensation reaction, okay, to form a dipeptide. But you don't really need to know the term dipeptide. Okay, we will talk about it more. But see, so the carboxyl group, right, and amino group will join together, right? A water molecule will be released, and a bond that actually bonds two amino acids together is called a peptide bond. Can? Peptide bond. I'd like you to highlight this on your notes. Okay, now the thing is this. So repeated condensation reactions with more amino acids, right, will give rise to a polypeptide chain. Okay, so every one circle here you see is one amino acid. So see, many amino acids will link, right, to form a polypeptide chain. Okay, so like monosaccharide, disaccharide, polysaccharide, right? So now this is amino acids. Okay, many will link together to form a chain, and this chain is called a polypeptide chain. Can? Okay, so like between, right, each amino acid you'd see here, okay, there's actually a peptide bond, a CONH here, that's a peptide bond. Okay, all right, so then we ask ourselves, remember now, you asked the question, that time in cells, right? We talk about what? Wow, ribosome synthesized protein or polypeptide chain. Now, what exactly is the difference, right? Now, a polypeptide chain, if you read this long text, is just, right, many amino acids, right, will link together to form an entire chain, about 2 to 50 amino acids into one chain. This is called a polypeptide chain. Can? Now, the thing is that on your notes, right, I think you'll be able to see this diagram. So you can see now, this is actually a polypeptide chain, right? But your notes, I think, wrote there, right? A protein molecule is made up of one or more of such chains combined together. So a protein, right, is like two polypeptide chain come and combine together. So there will be a very unique shape to this protein. So you see, a polymer of amino acids joined together, yada yada yada. So here, proteins can be made up of more than one polypeptide chain combined together. So this is a polypeptide chain. Okay, this is a protein, whereby there's actually, in this case, maybe two polypeptide chains that are linked together. So this is what we call a protein. Can? Okay? So talk about it so far. The elements that make up proteins, we have carbon, hydrogen, oxygen, and nitrogen, right? The sources of where we can get protein from, you can get from lean meat, egg white, tofu, right? These are some sources where we can get proteins from, right? Now, third point, classification, right? The basic unit is a amino acid, okay? Many amino acids can link together to form a polypeptide chain that's linked together by peptide bonds. Then once the polypeptide chain, as you can see over, wait, I need to get my directions right. Over here, okay, one polypeptide chain. So two polypeptide chains, or maybe three, can come together to form a structure. Then this structure is what we call over here a protein. Okay? Can Alrighty. Now, 4. The functions of protein. This one is Mr. Cho's favorite because out of all the functions, this is the easiest one. Okay? So, in your notes down there got 2 blanks for you to fill. Okay, number one, synthesis of new protoplasm, right? Proteins are being used to form new protoplasm. We talk about it, right? The growth and repair of worn out parts. So proteins is the one that come to help. And synthesize enzymes and hormones. Enzymes, you all know what it is already, right? Because you all learned last year. Hormones are actually chemical messengers that go around your body. This is also made up of protein, right? And lastly, formation of antibodies to combat diseases. We will touch on all these points when we come. Okay, so how Mr. Cho remember this, right? Synthesize means to make. Okay, synthesize and make what? Okay, Mr. Cho remember the thing P-E-A-H. Can we write on this thing? Wait, sorry, gotta forgive this dinosaur. Okay, I can't see the right button anywhere, the annotating button here. Okay, but the functions of protein, right, is to synthesize P-E-A-H. Can you all write it somewhere in your notes? P-E-A-H, protoplasms, enzymes, antibodies, and hormones. Can? So like the long story of carbohydrates, wow, form supporting structures, wow, synthesize nectar, blah, blah, blah. For proteins, just is being used to make four things: protoplasm, enzymes, antibodies, and hormones. Settle? Yeah. Alrighty. Okay, last one. Okay, of the thing, Burette test. Now, like I mentioned, you need to know how to describe the steps, okay, as well as you need to know how to describe and interpret the results. Okay, so how do we describe a Burette test? How to carry out? You guys have did it that day yourselves already, right? Okay, so the first step there, okay, so the test are same thing, put a lot of stars at this one because you need to know how to describe. Number one, add 2 cm cube of sodium hydroxide. Okay, this is a colorless solution, you had it that day, to 2 cm cube of sample in a test tube and shake thoroughly. As I mentioned, common mistakes are some people don't put the cm cube there, you'll be marked as wrong. Okay, be very specific. 2 cm cube of sodium hydroxide to 2 cm cube of whatever the sample name is in a test tube and shake thoroughly. Do not miss out the words shake thoroughly. Okay, then you add 1% copper 2 sulfate solution drop by drop and you shake after every drop. So these two steps are the steps to describe Burette test. Okay, then you observe. If let's say the copper 2 sulfate solution remains blue like that of this one, okay, the protein is absent. Okay, just write protein will be absent. But if the copper 2 sulfate turns from blue to violet, okay, so in this case here, right, purple, please go and strike off purple, go and put violet, okay, then protein will be present. Can? As mentioned, sometimes Cambridge might give you the word purple, like when you try your 10-year series, right, write purple, roll with it. But if people ask you, or if you were to write out in exams, right, write as violet. That's the most accurate color that we can write as for this. Okay, so with that, we have actually reached to try it out. Pause the video here first and try the 2 questions first. Okay, very fast one. I'll take you less than like a minute most prob. Okay, then when you're ready, then you press play again and then we finish off the last 2 questions. Okay, so you click pause. Okay, I'm just going to go on here. Okay, now, so the answer for question 1, right? A sample of egg albumin solution was tested using the Burette test. Which are the following of the results of test and deduction that can be made? So the answer will be C, right? Because egg albumin is actually protein, right? Your egg white. So obviously you expect a violet color to deduce that protein is actually present. Okay, this actually came out in 1991. Okay, for O levels in 1991. That's the year Mr. Cho was born. Okay. Oh no. Okay, wait. Okay. The thing actually. Alright. Okay. So the last one, right? Milk produces a red precipitate when heated with Benedict's solution. Right. So a purple color develops when the Burette test is used on milk. So using these results only, which nutrients does milk contain? Came out in 2011. You can see there's an upgrade in the questions. Burette test, purple color, right? Or we say violet color. Most likely you already know that protein is definitely present, right? So the options B as well as D will be striked out, right? So you're left with A and C. Now, Benedict's solution, right? A, the only time when it's a negative result that should come to your mind is that if it's a blue, if the solution remains blue, but no, right? It says a red precipitate is being formed. So that already gives you a clue that reducing sugars are actually present. Now my Mr. Cho's question, how much of reducing sugar is actually present? you should be able to recall that it is a large amount of reducing sugars is actually present. Okay, so the answer for this will be C, reducing sugar and protein. Okay, so in order to quickly summarize up, okay, for this video lecture, the most important thing is this, right? What are the elements that make up proteins? In this case, CHON, right? CHON, carbon, hydrogen, oxygen, and nitrogen. Okay, where are the sources to get proteins? You get your lean meats, tofu, egg white, okay, and whatever else that is put over there. Can 3. Classification. Amino acids can build up to polypeptide chains, can build up to proteins. Proteins can also break down into polypeptide chains and can break down into amino acids. Functions of protein: synthesize pair, protoplasm, enzymes, antibodies, and hormones. Finally, how do you conduct your Burette test? Add 2 cm cube of, I hope you are revising together, 2 cm cube of sodium hydroxide to 2 cm cube of solution. Shake the test tube. Okay, after that, add 1% copper 2 sulfate drop by drop and shake after each drop and observe. Then if the copper 2 sulfate solution remains blue, it means that protein is absent. If the copper 2 sulfate turns violet, means that protein is present. So then this is the checklist of, okay, I know everything I need to know about proteins already. I strongly encourage you to do the same for fats and carbohydrates, okay, so that you really make sure what you need to know for this chapter. Okay, and so that will bring the end to Mr. Cho's short e-lecture. I hope that this has been useful for you. I think I'll do up a short word doc, okay, a nice table, okay, so that for you to actually summarize your learnings in that table before I see you again. Okay, so holiday homework is only that 15 marks worksheet as well as your 10-year series for movement of substances, which I actually see most of you complete already, right? And the MCQ numbers that I've listed there. Okay, stay very safe for the host. Enjoy yourself. I'll see you guys soon. Okay, bye-bye.